Hey students, in this video we're going to cover the progress check for while loops. All right, let's get started. So for one, we are printing 987654321. All right, so for option A, num starts out at 10 and num is printed first. So this loop is going to print 10 through 1. For B, num starts out at 10 as well. Num is printed first, and we go to num can equal 0. So this is going to print 10 through 0. For option C, num is going to start out at 10, but first inside the loop, num is you subtract 1 and then you print num. And so this is actually printing from num equals 9 to 2 from 9 to 1. And this would be the same as having a loop where you have num is equal to 9 and while num is greater than 0. It's the same thing as if we did this and did num minus minus afterwards. So those are effectively the same thing. Nope, I want to share that here. Hold on. Where's my little... Right, here we go. So let's take that back. So anyway, C is the correct answer because we decrement num by 1 first, and then we print num. D and E are, again, both inclusive of the final value, so they're going to print 10 digits instead of 9. So that's why those two don't work. For number 2, number 2 is the same as the question that's on the for loops assignment, actually. I don't know how I didn't catch that, but the explanation is the first loop is going to print the number of times that B divides into A. And since for the second loop, since I starts out at 0, if you increment by B and you stop at A, you are effectively checking the same thing. How many times does B divide into A? And the only time they're always going to print the same thing is when A remainder B is equal to 0. So in the case where in the case for A and where A and B are both even, for instance, you could have a case where like A is 6 and B is 2. So both of the loops will print the same thing, but you could also have a case where like A is 6 and B is 4, and then they won't. So sometimes if you look at A or B, there are going to be cases where you can choose numbers where the remainder when A divided by B is 0, but there are also going to be cases where A remainder B isn't 0. Actually, A, B, and C all have those possibilities. So D is the correct answer. Number 3, if we just look at these conditions one by one, so if X is less than 0, you won't if the condition is while X is less than 0, you won't enter the loop because X starts out as 1. If the loop condition is X is less than or equal to 1, you'll enter the loop. But since the only time you print something is when the remainder divided by 2 is equal to 0, so X is going to be 1 remainder 2 isn't 0, so then you're going to increment 1 by 2, so you're going to get 3, and you don't print anything. So then in the case where X is less than 10, then you're going to enter the loop where X equals 1, and so then 1 remainder 2 is 1, so you won't print anything. You increment by 1, you're going to get the next odd number, which is 3, and you're going to run into the same condition. 3 remainder 2 is 1, so you don't print anything. You go up to 5, 7, and 9. So for none of these do you actually print anything. So 1, 2, and 3 all result in nothing being printed for different reasons. Number 4, so for a question like this, I would say just choose 2 values and see what happens. So say num is 7, num 3 is 7, and num 2 is 2. So you're basically running a loop from 2 to 7, And since num1 starts out at 0, you're just adding the value of num2. So you're going to have num1 is going to equal 2 plus. So then we increment num2 by 1. So you're going to have 2 plus 3 plus 4 plus 5 plus 6. And since we stop when it's less than 7, so we won't actually get to 7. So all we're doing is adding up the numbers from 2 to 7 minus 1, which is going to equal 6. So you're just doing the numbers from 2 to num3 minus 1 inclusive. So that's the answer to that. It's clearly not the product because we're not multiplying, and it's not the sum of the two numbers because it's just not based on what the question, how we lay out the loop. So the only two reasonable answers are D and E, and it would be D if it was less than or equal to. For number 5, the key thing here is that X starts out as 1, and so we're looking again for a condition that only prints 1, 3, and 5. So since X starts out at 1 and inside the loop, we update X by adding 2, we are going to get odd numbers. So when X is less than 6, then you're going to print 1, add 2, then you're going to print 3, add 2, print add 2, then print 5. And so then when X is 7, you won't go back into the loop. So you're going to print 1, 3, and 5 for option 1. For option 2, if X is not equal to 6, then since X starts out at 1, that's the key part. You're going to add 2 each time. So you're going to get 1. X is going to be 1, 3, 5. You skip 6 and go to 7 and just keep going. So for option 2, you're going to get an infinite loop because X started out as an odd number. For option 3, X is less than 7. You're also going to get 1, 3, and 5 because it's not less than or equal to 7. So when you jump into the loop, X is going to be 1. You're going to print 1, add 2, and get 3. Print 3, add 2, and get 5. Print 5, add 2, and get 7. And you won't go back into the loop because 7 is not less than 7. So both 1 and 3 print 1, 3, and 5. 2, it would just print all of the odd numbers up until the computer says we ran out of stuff to print because we used up too much memory or something. You get an infinite loop. So the answer is 1 and 3 only. For number 6? So I just wrote down the iteration, like what happens in each iteration. So if we call mystery 6, that means that n starts out at 6. The first time through the loop, you can see what this is. I'll give you a moment to look at it. So essentially, we're just adding the value of y to x each time and subtracting y from x the second time. So as we go through, the first time we're going to get 2 and 1 for x and y. N is going to be 5. Then when n is 5, you're going to do 2 plus 1, which is 3, and 3 minus 1, which is 2. And we just keep doing that until we get to n equals 2. And the result of that is going to be that x equals 8. For number 7, you're using that same loop. Now, the way this is typed is a problem for me. It is, in my opinion, somewhat unclear as to if point A means before the loop or after these things are executed. Some of that matters in terms of how you take that stuff in. The one that has to be true is E, and that's because inside the loop, to do anything inside the loop, n has to be greater than 2 because that's the only time you can use the loop. So that's why E is correct. If you have individual questions about this one, talk to me because there are a lot of possible questions that you might have. But E is the one that's definitely true. Because n has to be greater than 2 for you to be inside the loop. For number 8, this should look familiar because you did it in your project. If input value remainder k equals 0 should be that condition. That's how you know something divides into another value. So A is the correct answer here. I'm pretty sure that's pretty straightforward for everybody. For number 9, so we have this loop that's running until num is 0. So the first time through the loop, result is going to be 0 times 10 plus 4. And we just keep multiplying by 10 and adding the remainder and trimming off a number. And the final result of doing that is going to be 475 times 10, which is 4,750. And then we add 2 and we get 4,752 for number 10. Careful here. So the loop is going to run while either one of those conditions is true. So at some point, sum is going to be greater than 12. It's going to be the 12th time that this loop runs. But notice K is never incremented. I actually had to check the PDF to make sure in this blank space some code wasn't missing. But since K is never incremented, even when sum less than 12 fails to be true, this other part, K is less than 4, is always going to be true because K equals 1. So nothing is going to be printed because of an infinite loop. Number 11, the final question here is, this should also look familiar. It's the method that we did in class where we take out all of the occurrences of a particular string. In this case, we're taking out NG. So the first time you go through the loop, if you want to see what happens, the first time you go through the loop, I'm just going to use the sing song thing that's here. So the first time we go through the loop, we're going to take out the NG. So we're going to have SI space the space song. And so then X is going to turn into the new index of NG, which is going to be, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be the index value of 9. It's going to take that out. And so then at the end, it's going to do index of NG again, and it's going to get -1. And that means the loop stops executing. And so SI, the so, is going to be what's printed. All right. So that's that video.